Okay guys, welcome back. So in this video I will be talking about a new concept in which the height is somewhat changed. So there is a new problem here. So the problem is alright, an object is projected an object is projected at 40 meters per second from the ground at t equals 0. It collides with a wall of height 4 meters. The distance between the initial position and the wall is taken as 8 meters. 8, right? The distance between the initial position and the wall is 8 meters. So the question is asking, find the angle between the velocity and the horizontal direction. So I'll draw a simple diagram to illustrate this question. So what I'm saying is, now taking a simple plane like this, right? Simple plane like this, and if it has velocity, it has been given as 40 meters per second, and the angle theta, it goes to height like this. Now h is not the maximum height of the object, can be maximum height, but we don't know, right? It goes to some height h in which it collides with the wall. So this object here, it goes here, like this to here, and then at here it collides. So I'll take this point as A, take this point as B, t equals 0 at A, and t equals t at B. So this is now a simple problem. Only thing is now we don't find the total displacement to be 0, the vertical displacement to be 0, total horizontal displacement after the total horizontal displacement is not 0 at time t, the total horizontal displacement will be h at time t. So we need to find the value of theta. So they have given the value of r here. R means the distance between the initial position and the final position. So from the horizontal coordinates, the initial position will be A here, and the final position will be here. So r is here. R is actually equal to this range. So this is the range of the object. The object cannot go further than this. The wall is very high. The object cannot penetrate the wall, so the object collides here, and sometimes it will go down, or it will go somewhere. You don't need the concept after hitting. So these are, so they have given this as 8 meters, h equals 4 meters, and r equals 4 meters, and r equals 8 meters. Alright, so we have to find theta. So to find theta, we don't know the time t, so we don't know the velocity at b as well. We don't know the velocity of b. So if we eliminate the value of t, we have to find only the value of v. We don't know the value of v, so we can use v squared equals u squared plus 2as. So the other all three equations need the value of t. So we don't know the value of t as well, but we can take a substitution. If we put the value of we take the value of r and take in the value of t from that, we can find the exact value of t, because theta is unknown. Theta is the quantity we have to find. We don't know the value of theta, so we can find the exact value of t, but we can take a substitute from the value of t like this. If you take the value between a to b, take the motion to be from A to B, I can put S equals ut plus half at square in this direction, so that we don't find the final velocity. We don't know the final velocity. We don't have a way to find the final velocity as well. But we know the value of S. If you put in the horizontal direction, that is given as 8. The initial velocity is 40, but the velocity in the horizontal direction is 40 times cos theta times t. So time t equals 0 at A, t equals 0 at A, and t equals t at this position where the object collides. So t equals is t. So a is equal to 0 because this is in the horizontal motion, the object is in the horizontal motion and the gravity is acting directly downwards. So the motion, the velocity and the gravity are perpendicular to each other, so there is no acceleration of the object. So 8 equals 40 times cos t, so t is equal to, this is 1/5, 1/5 cos theta. T equals 1/5 cos theta. Now you don't know the value of theta, so you can find t. So actually you have to find theta. So to find theta you need the value of t, but you don't know the value of t, so you can directly find the value of theta from t. So the only other option, apart from the since we don't know the velocity at the point of collision, the only other option is to find is to put s equals ud plus half at squared in the vertical direction. So I put that, considering the motion from A to B, s equals ud plus half at square in the vertical direction, right? So the vertical displacement of the object is not 0 now. The vertical displacement of the object is 4 meters. So that's the distance. So distance from the initial position to the position where it hit. It's given as it's given as 4 meters. 4 meters. So s is equal to 4. Right? This is 4. U means the initial velocity of the object is 40 sin theta. You don't know the value of theta, that's the one we will find. 40 sin theta times t. T is equal to 1/5 cos theta. So plus times minus, plus times half times minus g is minus half g times t square. So this is minus half t square. So this is minus half times g is 10. So half times 10 is 5. T square is 1/5 cos theta square. So here you can simplify here. 5 times is 8. This is 1/5 will be remaining. Here 1/5 will be remaining. So that this equation now sin theta by cos theta, sin theta divided by cos theta is equal to tan theta. 1/cos theta is sec theta. Sec theta squared is sec square theta. Now you know that sec square theta is equal to 1 plus tan square theta. So that's from trigonometry. So if you are not studied, if you are not well versed in trigonometry, I invite you to watch my videos and come back here. So that will be easy to solve this problem. So this is which equals to 4 equals 8 times 4 equals 8 times sin theta by cos theta is tan theta minus this is 1/5 1/5, right? 4 equals 8 times tan theta minus 1/5. Sec square theta is 1 plus tan square theta. So I multiply by 5 here. So this is 20. This is 20 and this is 40 theta tan theta minus, so this will be minus 1/5 times 5 is 1/5, 5 times 1/5 is 1, so 1 times 1 plus tan theta square, so that multiplied by minus 1 is minus 1 minus tan square theta. So I'll take tan, this is actually equation, quadratic equation of tan theta. So we have to find the value of tan theta and then take the arctan of the tan inverse to find theta. So I'll find that. So to find tan theta, I'll take this side. This is tan square theta and this will solve to tan square theta minus 40 tan theta plus 21 is equal to 0. Tan square theta minus 40 tan theta plus 21 is equal to 0. So this is a quadratic equation of tan. So to find tan theta, I'll take the equation tan theta equals, right? So this is in the form ax squared plus bx plus c equals 0. Ax squared plus bx plus z equals 0, where x is equal to t and a is equal to 1, B is equal to minus 40, C is equal to positive 21 or plus 21. C is equal to plus 21. So we can substitute here. Tan theta equals minus B minus tan theta equals so you know that x equals minus b plus or minus b square minus 4ac divided by 2a root of that minus b plus or minus root of b square minus 4ac divided by 2a. So x is equal to here tan theta equals minus b. So you know b is equal to minus 40, so minus b is equal to plus 40. Plus or minus b square equals to minus 40 square, that is equal to plus 40 square, which is equal to 1600 minus 4 times 1 times c is 21. So 4 times 1 times 21 is 4 times 21, that is equal to 81 divided by 2 times a is equal to 1. So this is actually not a perfect rule, I think so. This is 9, this is 1519 by 2. So tan theta is equal to 40 plus or minus root of 1519 by 2. Now if you take the positive root, tan theta is equal to 40 plus 1590 divided by 2. So that will be positive. If you take the minus root, tan theta is equal to 40 minus root 1519 by 2. So root 1519 is less than the root of 1600, which is less than 40. So 40 minus 1519 root by 2 is greater than 0. So both answers will be greater than 0. So that means there should be 2 angles. So that's what we calculated in the last video. There should be 2 angles at which a projectile can occur. So you have to take the 2 angles, but in the first angle it would be probably some angle, you have to find that, then find the arctan value and then find theta. So theta equals straight line arctan, or arctan is also called tan inverse sometimes, arctan 40 plus or minus 1519 by 2. 1519 by 2. So there are 2 angles at which theta satisfies this equation, and since theta satisfies this equation, there are 2 angles at which the projectile can occur. So in this video we talked about the motion of an object with some angle theta in it, at some angle theta, and moving to height h, where the vertical displacement, the total vertical displacement of the object is non-zero. Okay, so in the next video I will be talking about the motion of an object in inclined planes, on an inclined plane, both on the upper direction and on the downward direction. So I invite you to watch that video as well. So thanks for watching this video and see you next time.